Hello everyone, my name is Raviteja and today I'm going to explain our mini project which we have done in third year second semester, and our project title is Human Emotion Identification and Classification from Text using NLP and other machine learning techniques. Now, what is our project? Our project is nothing but emotion analysis, which is a technique which already exists in natural language processing and machine learning, and it is crucial in understanding how we as people express our inner thoughts and feelings through text. As nowadays, a lot more than before, we are using social media day and every day, and physical contact is very much absent. And discerning these emotions from textual communication is very challenging. And this emotion analysis, which is also similar to sentimental analysis, it enables us to determine the polarity of any sentence or any message and categorize the emotions that we obtain from that message into either positive or negative or neutral, along with their probabilistic scores. Where in our project we take a message, any message, and we determine the emotions in that message and give a probability to each emotion, and also identify the polarity of that particular message. And our project involves feature selection and emotion identification using the NLP and machine learning techniques such as classification and evaluation. And we are also going to be using transfer learning and BERT, which is already an existing model which is used to check the text. And this emotion analysis has many applications. We can use it to find the emotions in social media posts, messages, and also it can be used in the real world as well to get product feedback surveys and much more. And this emotion analysis will also help us enable a better understanding of the individuals in various real world applications. Now, moving on, there are some existing systems in this field of emotion analysis, and the experts from various fields such as NLP and computational linguistics and intelligence have been working for so long on classifying opinions, sentiments, and emotional states that are present in the texts. But a major challenge for them is the limitation of the data sets, which are also limited due to their availability with labels for various ranges of emotions, which makes it difficult to develop accurate systems for understanding these emotions. And it is also important that these systems consider the cultural differences and the context in which the emotions are expressed. And another challenge in this is the deep learning models is that they are commonly used for this task, and they are also difficult to understand in terms of how they make the decisions. So in order to build those better systems, we need to overcome these limitations by collecting more diverse emotion data sets that are also labeled with much more emotions, and which also consider those cultural differences, and also develop the models which are sensitive to those nuances. Additionally, we should also aim to create a system that are more transparent and explainable so that we can better understand how they are able to determine the emotions from the given text. Now, our proposal. We propose an approach using the machine learning and NLP to create a reliable and accurate system for this text-based human emotion identification and classification. And this system, we aim to address the shortcomings of the existing systems and provide a thorough comprehension of the human emotions conveyed in textual data by utilizing the transformers models like the one we mentioned before, the BERT model. And also we will be using the Roberta model, which is a very famous model used for this text identification. And also our training approach is also going to be different. And the system which we create will also be using the Go emotions data set, which contains 27 emotions, which is a wide range of emotions. And we will use it for training and testing, where we also do feature classification by tokenizing those data using the one hot encoding method. And then we use the custom trainer to fine tune the model using our custom parameters. And we also want to add the sentimental analysis to our system as well, utilizing the Vader vocabulary, which is an already existing model used for the sentimental analysis of text. And finally, we want to combine our output of emotions along with the Vader sentimental emotion together and show it as an output. Next, let's look at our UML diagrams. Initially, the use case diagram only contains one user with multiple back-end users that are pre-processing and natural language processing and sentiment analysis and emotion analysis, where initially we consider our text and we take the text only with the keywords and remove all the symbols and only keep the alphanumeric letters, and then we identify the text using our transformers, and then we perform a polarity check using sentimental analysis, and then we identify the emotions and classify it and obtain a probability score for each emotion. Our data flow diagram is also very similar, where we initially take the tweet. We can also consider tweets from Twitter as well, or any other sources of textual data, and we will do the same of pre-processing and NLP and sentiment analysis, and also identification of emotion and classification, and finally obtaining the probability score. In our sequence diagram, we show the sequence in which these steps are done, where we initially consider the tweet, after that keywords, after that we do the identification, after that which we perform the polarity check, and finally obtain the emotion along with the probability score. And also our activity diagram, which also explores which also showcases in depth how all the processing is done, after which activity what will happen, where we initially consider the text and we pre-process it, we identify the keywords using the tokenizer, and then we classify the sentiment, where we take the message and we check whether it is a neutral message or is it a non-neutral message. If it is a neutral message, we put it in the neutral set. If it is a non-neutral message, we check for its polarity, either is it positive or negative, and put them in their respective sets. And after putting the text into that particular set, we identify its emotion and classify the emotion and also calculate the probability score. And finally, our architecture diagram, which showcases the structure and our sources from where we have taken the text and how we will calculate the results. Now let's look at our implementation part, where initially we are importing our required libraries and dependencies that are nothing but transformers library and the datasets library, and also the torch library which we use for pre-processing. Now here we also import numpy and datasets, and initially we consider the two datasets, which is a training dataset and testing dataset. And now we are importing our transformers, the Roberta transformer and the tokenizer model. And here we define our function that will pre-process the dataset, and we are in that pre-processing we are converting those labels which you obtain in the dataset into one hot encoded representation, and we are returning the pre-processed dataset. And this pre-processing method is applied to both the training dataset and testing dataset respectively, and we are also removing some particular columns which we do not require. Now we are considering our training arguments to which we use for our custom trainer, which is here the custom trainer, where in training we are also directly computing the loss itself during the training itself, where we are calculating the loss of training loss and validation loss, that is also evaluation loss. And these are our arguments, and this is our trainer, custom trainer, and here we are training the model. As you can see, we have done 3 epochs, and by the end of the training our training loss was at 1.70 and evaluation loss at 1.66. And after training our model, in order for our model to predict the emotions correctly, we are declaring a dictionary in which we contain all the emotions which are mapped to their respective labels and indices. And we are also importing NLTK to implement our Vader lexicon model, which is used for our sentiment analysis. And we are finally defining our custom predict function, which is used to predict the output given the inputs. Now let's look at the execution of our model. We just give the predict function and we write our input text which we want to predict. And as you can see, it is predicting properly of this particular message. It has predicted 4 emotions along with the sentiment, that is, it is a negative message. This is an example of another message. And it not only works with this simple plain text, also it also works with tweets as well, as you can see here. It also works with messages with emojis as well. And now I finally conclude our video by thanking our project guide, Dr. N. Rajshekhar, who is a professor at IT department at GRIT. and also would like to thank all the faculty of IT department for their continued support in our project. And my name is Raviteja, and our other group members are Datta Sai and Vamshi. Thank you all and have a great day.